Okay, last time in space physics, we talk about the life cycle, complete life cycle of the star, how it starts to um take the shape of like red giant or the stable state and how it starts to explode and converts into the dark planets or the black holes. So that complete life cycle of the star we discussed in the last class. And today we are going to talk about the red shift and the blue shift, the Doppler's effect, and the concept of the galaxies, how we identify that the galaxies are moving away from each other. And this is also the evidence of expanding of the universe. And by using this theoretical information, we can also like give some evidence for the Big Bang theory also. So on the theoretical basis, we know that there is no practical evidence available. But according to all the theory, all the galaxies that the behavior of the galaxies and the space bodies, so all actually gives you the evidence that universe is expanding and the theory of Big Bang is also right. So we are going to talk about galaxies and redshifts.
Yeah, before we start, I have a question.
Hmm.
When does a star explode into a planetary nebula, and when does it explode into a supernova?
Uh, After red supergiant, it converts into supernova. Basically, initially we have protostar, then we have main sequence star like sun. So sun is the
All
main sequence
right,
star. And after when the hydrogen like run out for the fission reaction, so then it starts to convert into red giant or red supergiant. And if we talk about red supergiant, so the red supergiant converts into supernova and then into neutron star and black hole.
and the red giant explodes into a nebula.
Yes.
All right, thank you, sir.
Okay, so galaxies and the redshift. And the concept of redshift is very simple. In electromagnetic spectrum, in the chapter of the light, we already discussed about red color and blue color, violet color. So we know that the wavelength of the red color is greater than the violet or the blue color. So that's why the concept of red shift is also like given over here because of the idea of that wavelength. So normally, if we consider any body, let's suppose if there is an ambulance and ambulance is stationary at a point, so sound is like continuously traveling from one point to another point in a uniform pattern, just like in the first diagram. So initially, we have symmetrical pattern. Okay, so we are talking about the example of an ambulance. Ambulance is standing, it is stationary, and sound waves are like traveling around it. So we have symmetrical wavefronts. When ambulance is in stationary or car is in stationary state and it is generating a sound waves. So when car starts to move, so you can see on right hand side the wavelength, or we can say the waves which are actually generating in the first diagram, which are symmetrical. Now it is not symmetrical. The distance on the right hand side is completely different from the distance on the left hand side. So the wavelength on left hand side starts to increase and the wavelength on the right hand side starts to decrease. So this happens when a body starts to move from one point to another point. So if observer is placed on left hand side, let's suppose, So basically car is moving away from this observer, and another observer is standing over here. So car is moving towards observer B. So for observer A, wavelength is increasing and frequency decreases. And for observer B, wavelength decreases, frequency increases. And this also happens in our daily life. Let's suppose if we are standing on the footpath uh, or at some position, or let's suppose if we are in a stationary state in the car, or if we are driving a car or moving in any vehicle. So we observe that if ambulance is moving towards you and when ambulance is moving away from you, so you observe two different frequencies of sound, right? So that actually happens because of this effect, which is called Doppler's effect. This whole effect is called Doppler's effect. And there is also a formula of Doppler's effect, but in your syllabus in O levels, it is not included. That will be included in your AS. So in that, we also discuss that how to find out the observed frequency. But right now, we only need to talk about the wavelength and the frequency, and concept is very simple. When object is starts to move away from observer, so wavelength will be increased for observer from which the body is moving away. And if body is moving close to any observer, so wavelength starts to decrease for that observer and frequency starts to increase. So this is the concept of the Doppler effect, very simple. So when body is in rest state or in a stationary state, so we have symmetrical wavefronts. But when body starts to move, so a moving object will cause the wavelength. It's up to you. You can take the reference with the term wavelength, or either you can take the reference with the term frequency. We all know both are inversely proportional to each other. So if you know about one quantity, so definitely you can easily identify the second one. So when body starts to move, so it will cause the wavelength or the frequency of the wave changes. And according to our diagram, we have observer A over here and we have observer B on the other side. So let's suppose according to this diagram only, if we consider observer A. So for observer A, we can write down wavelength increases for observer A and frequency decreases. And if we take the reference from observer B, so for observer B, it will be inverse. Frequency increases, wavelength decreases. So this is the idea, and this is called a Doppler effect. And since if we talk about those bodies which are moving away from any other body, so that will also be categorized in the red shift, because red shift means red color also have greater wavelength. So that's why we also categorize them in the concept of the red shift. So if an observer or if an object moves away from an observer, wavelength increases, and this is known as redshift. So this is the concept of redshift. And you can also define the idea of the redshift as, if they ask about the redshift, so you can define, because red color is related to the electromagnetic spectrum. So we can say an increase in the observed wavelength of electromagnetic radiation emitted from receding stars and galaxies. So if you consider a star, so if a star is moving towards the planet, if we consider our planet, so if a star is moving towards our planet, so that is red shifted. And if a star is moving away from our planet, so that is uh, red shifted. So when a star is coming close, so that is blue shifted. So this is the idea of the red shift and the blue shift. So if a star coming towards the planet, so that is called blue shifted. Okay, next we have one more idea in the form of electromagnetic spectrum pattern that you also got in your past papers, pattern like this. So in past paper, we also got one pattern like this. They are asking about which body is moving away, which body is moving close. So how we identify? So first of all, The first pattern shows the light spectrum that is coming from a close object such as the sun. And the second pattern is light spectrum from a distant galaxy. So in this diagram, you can see if you consider the second diagram. So in second diagram, you can identify that there are many black lines near to the red color. So there are so many these black lines close to the red color. And in the first diagram, there are only like three lines in the red region. So basically, these black lines shows you that if some body or galaxy is moving away, so your spectrum will be shifted towards the red side. So that is called red shifted. And if object or galaxy is moving close to the object, so then your pattern is going to be shifted towards blue. So there will be there will be less line pattern on the red color side. Okay. So when the star or galaxy is moving away, so spectrum is shifted towards the red color. And vice versa. When a star or galaxy are moving close, so this spectrum is like shifting away from the red. So this is the idea. And from this redshift idea and all this concept, we got one more thing. If galaxies are moving away, it means that the universe is expanding because the galaxies have more space to travel. So that's why they are moving away. So it means that universe is still expanding and there is so much area or so much space is available for the body. So they can travel, they can move to that point. So if galaxies are moving away, it means that the universe is expanding. So this is the idea of the redshift, and this is the concept of the expansion of the universe from the idea of the redshift. So any confusion in this?
No, sir.
Okay. Okay, so if we consider some questions related to the space physics.
Sir, could you re-explain this part again, please?
Redshift. Okay,
No,
basically,
the diagram.
okay, in the diagram, you can see in the first diagram, the black lines are very less in the red region, this one, right? And in the second diagram, you can see there are so many lines in the red region. So it is like when you got signals, right? When you got some signals on any screen, so that will show you that this is the frequency of some signal which are actually moving. So when you have less lines in the pattern red, so it means galaxies are coming close to any observer. So their output will be different, and their output will be that spectrum is shifting away from the red. Okay. So there will be less spectrum close to the red color. And when the galaxies or the star are moving away from any observer, so it means the wavelength is going to be increased. And when wavelength is going to be increased, so in electromagnetic spectrum, it is shown by so many lines on the red region. It means red shifted. So these black lines actually shows you the idea of the red shift or the blue shift. If galaxies are moving away, so these lines are shifting towards the red. And if galaxies are moving close to any observer, so it means these lines are shifting away from the red. You can see these two lines are here in the first diagram, but there is no line in this region because lines are shifted towards the red color. Okay. And in the
Yes,
first,
sir, understood.
yes, lines are shifting away from the red color. So basically, this is the pattern to show the electromagnetic spectrum for red shift and blue shift for the space bodies. And for the questions, okay, this is the same file that we actually use for the topical questions. So in this, we also have some questions related to the space physics, and there are only few because we don't have past papers of it. So you can see there are 21 pages in this file. So question number 10 is the sun is a star and in a stable part of its life cycle. We already know because it is the main sequence star, so that's why it is in a stable state. Using ideas about forces, explain how the sun remains stable in this part of its life cycle. We know that there are two types of forces acting on the star or on the sun. One is the gravitational force that is acting inward, and second is due to the fusion reaction, right? So the first part is very simple. that first of all we have inward force.
Or is it because the gravitational force and the fusion force, that force, it's
Balance
equal?
each other. Yes. So inward force due to gravity between particles. So this is the first force, and this force is balanced by, yes, by an outward force. Right. So this is the first part. And in the next part, describe what happens to the star of similar mass to the sun at the end of the stable part of their life cycle. So now this is the stage before red giant or super red giant, right? Because when hydrogen run out, so we know that it is going to be converted into red giant or red supergiant, super red giant. So if we have stars of the similar mass just like the sun, so at the end of their stable part, hydrogen runouts, so there will be no more fusion reaction can happen. And gravitational force will be greater. And the core starts to collapse. And we know that the outer layer starts to expand. After that, a star becomes a red giant. So basically, you can see this is the same idea, same concept that we already discussed in the formation of the star, in the life cycle of the star. So you may phrase according to your idea that how you explain your whole concept in the given space according to the question. But the main thing is if you know about the exact step what they are actually asking about, like they ask about end of the stable part. So after the end of the stable part, we have red giant or red supergiant. So first of all, you need to know about that step. Then you are able to explain the idea what actually happens in the red supergiant or red giant stage of the star. And in the other part of the question, because now hydrogen has actually run out. So when hydrogen run out, so helium continues the fusion reaction. So in the core, helium nuclei fuse to make. And after that, what happens? So when helium is completely used up, so again the core collapse and becomes a white dwarf. So this is the explanation for the B part of this question. And in the C part, that is calculation base, the orbital speed of Earth around the Sun is 30 kilometer per second. Use this value to calculate the distance of Earth from the Sun. Show your working, state the unit of your answer. So the orbital speed of the Earth is given 30 kilometer per second. And we know that the formula is 2 pi r for one complete circumference divided by the time period. So speed is equals to 30. And let's suppose if we talk about one complete year. So in one complete year, there are 365 days. In one day, we have 24 hours. In 1 hour, we have 60 minutes. And in 1 minute, we have 60 seconds. So this is the total time for uh, taken by the planet or to complete one complete year. So these are the values, and from these values we can easily calculate the answer of r, that is the distance. So r will be equals to divided by 2 pi. So 30 multiplied by 365 multiplied by 24 divided by, we will get very lengthy answer like this, because we know definitely the distance between the earth and sun is not very small. So we can write it down 1.5 exponent 3678 kilometers, because we take the speed in kilometers. So that's why distance is also in kilometers. And in the D part, the light emitted by the distant galaxies shows various amount of redshift. State the name of the galaxy that contains our sun. So we have to write down the name of the galaxy. Before the sequence of the star, we studied that there are billions of galaxies are there. And from all those galaxies, we have our solar system in one of the galaxies, which is called Milky Way. So Milky Way is the name of the galaxy in which we are living. And in the second part, state what is meant by redshift, describe how it is caused. So we discussed about the redshift just now. So when the wavelength observed from galaxy moving away from Earth increases, so if the light is redshifted, so it means that galaxy is moving away. And in the third part, an astronomer compares the spectrum of light emitted by the sun. So it observed the light emitted by the sun with the spectrum of the light emitted by distant galaxy P and Q. So we have two galaxy and one sun. So you can see sun, galaxy P, galaxy Q. Now the question is, figure 10.1 enables the astronomer to deduce about galaxy P and Q. Explain astronomers' reasons in your answer. So this is the diagram that astronomer deduce from the galaxy P and Q. And also you need to mention the reasons. So basically we know that sun is stationary. So sun is not moving. It means that there will be no shift for the sun. There will be no red shift. There will be no blue shift for the sun. And secondly, if we have galaxy P and galaxy Q, so both galaxies are moving because you can see, you can compare these lines with the sun. So the distance of this line is, and if you compare with galaxy Q, so galaxy Q is moving faster as compared to the galaxy P because the difference of the lines as compared to the lines in the sun or lines given in the spectrum of the sun is greater for Q. So it means galaxy P is moving away and galaxy Q is also moving away but with faster rate. So this is redshifted and this is also redshifted, but it is more redshifted than P. So this is the concept of the redshift. So this is the idea, and you need to also mention this explanation in your answer one by one, because we already mentioned all the thing. You may start from the sun. Sun is the stationary, so there will be no shift for the sun. Galaxy P is moving away from the sun, so there will be red shift for the galaxy P. And galaxy Q is also moving away, but as compared to galaxy P, galaxy Q is moving faster. So the redshift of galaxy Q is greater than the redshift of galaxy P. So this is the observation of the astronomer also, and we just explained that observation of the astronomer in this question.